One-step equations. I can solve equations by finding the inverse operation of add, subtract, multiply, and divide. So inverse means opposite. So we're going to solve these equations. They have equal signs in them by using the inverse. The inverse of adding would be subtracting, subtracting would be adding, multiply would be dividing, and dividing would be multiplying. So you want to think of an equation kind of like a teeter-totter. And a teeter-totter will have a little place in the middle where it balances. This is your equal sign right here. So you need to balance, if you look at this one, we would need to balance a y and something that is 9 pounds, let's think of it that way, by something that's 15 pounds. So if this person who's 9 pounds jumps off, we have to have 9 pounds come off this side in order to be equal. So that way the teeter-totter won't tip one way or the other. How you show this is we're going to draw a line through the equal sign to show that whatever we do to one side, we do to the other. So in this case, we have y plus 9. We want to get y by itself, so we're going to subtract 9 from both sides. By doing that, 9 minus 9 equals 0. So there's nothing there, so we bring down the y that's left on this side of the teeter-totter. Over here, 15 minus 9 is 6. So in this case, y equals 6. I can check that by saying, well, if y plus 9 equals 15, we would have 6 plus 9 equals 15. And 6 plus 9 is 15. So 15 equals 15. They check out. So today we're working on how to show this by showing whatever you do to one side, you must do to the other. So here's another one. We draw our line down. We want to get x by itself. Well, x is minusing 5, so the inverse of minus 5 would be to add 5. So we need to add 5 to both sides. Minus 5 plus 5, or think of it as 5 minus 5, again cancels out, so we cross them out to show it's 0, and x equals 15. So again, I can think if I plug in 15 here, 15 minus 5 is 10, so it would check out. You go ahead and stop the recording and try this next one. When you are finished, check it to see if you are correct. All right, welcome back. Let's check. Let's draw our line down. Since I am subtracting, the inverse would be adding. So I'd add 1 to both sides. And y, because 1 minus 1 is 0, they cancel out, would equal 4. And y, or 4 minus 1, which is 3, equals 3. So that's how you show adding and subtracting. Now if you are multiplying, because you see, remember between a letter and a number, if there's nothing between, it's multiplying. To show the inverse of multiplying, we're going to use the fraction bar of dividing. We're going to try not to use this symbol anymore. So we're going to divide, because the inverse of multiplying is dividing, so we're going to divide both sides by 8. 8 divided by 8 is 1, so 1 times anything is itself, so we're left with x. 24 divided by 8 is 3. Again, we can check that by saying 8 times 3, which we've substituted for the x, equals 24. 8 times 3 is 24, equals 24. It's checked out, so we know it's right. So let's try this one. We draw our line down. We need 3 times something gives me 12. Well, we're multiplying, so the inverse of multiplying is dividing. Again, we use the fraction bar. This cancels, and y equals 4. Again, we can check it. 3 times 4 equals 12, so it checks out. Again, stop the video and try this next one. When you're done, hit play again to see how you did. All right, welcome back. Let's take a look. So I draw my line down. I'm multiplying, so to show multiplying, I'm dividing. Divide both sides by 6. Cancels, because that is 1. 6 divided by 6 is 1, so I'm left with t. And 66 divided by 6 is 11. That's how you show, because you're multiplying, the inverse is dividing, so that's how you show division. Last one is dividing. This is the only one that's not written underneath. The inverse of dividing is multiplying. So I draw my line down. How I show multiplication is by a dot, because we no longer want to use the x, because x looks like the variable x. So I'm dividing by 5, so the inverse is multiplying by 5. Multiply both sides by 5. Well, if you think of this as a fraction, this would be like 5 over 1. So when I have a numerator and a denominator, they can cancel out when I'm multiplying. So I'm again left with x over 1. Well, that's just itself, so I'm left with x on this side equals 30 times 5 is 150. So let's check. If I put 150 divided by 5, I would get 30. Last one, we draw our line down. Here I am dividing by 7, so the inverse is multiplying by 7. So I show multiplication by the dots on the two sides. This 7 and this 7 would cancel because one's a numerator and one's a denominator. I'm left with a over here, and 7 times 8 is 56.